Birmingham, England, April 2014. A beautiful swirl of cloud delicately twisting through the sky. These are wingtip vortices, aviation and atmosphere making art. Without very specific atmospheric conditions, these patterns would be impossible. Karen Kusiba from the National Center for Severe Weather Research deciphers the sight.
Wingtip vortices are visualized when you have something that could illuminate what the atmosphere is doing. What you could see is not just one vortex, but commonly two counter-rotating vortices following the plane.
The clouds make the vortices visible, but aircraft produce them all the time, corkscrewing through the air as they pass through the skies.
So just because you can't see that it's happening doesn't mean it's not happening.
The magical display is created thanks to the shape of a wing. As it passes through the sky, it disrupts the flow of air. This disruption changes the pressure above and below the wing. Higher pressure develops below the wing, lower pressure above. This creates lift. But at the wingtips, the high pressure escapes around the sides. This circular motion of the air around the tip becomes a spinning vortex as the wing moves forward. The wings of a plane create the wingtip vortices, but they need cloud or even smoke to make them visible. Tests have been carried out to study the phenomenon. Colorful smoke is released from a tower as a plane flies by. The resulting wingtip vortex creates a powerful multicolored cyclone. Incredible to look at, but potentially cause for alarm. Pilot Jared Hodge explains.
A wingtip vortex is a horizontal tornado. It disrupts the air immensely. So if an aircraft is following another plane that's creating this wake turbulence and flies through it, it could actually roll the airplane over if a precaution isn't taken.
An aircraft has just left this runway, but disturbingly, wingtip vortices can remain in the air for more than 3 minutes. Invisible to an approaching plane, it spins and crashes in the unexpectedly disrupted air. Planes create the vortices in the sky, but back on the ground, Randy Cervini is creating them in the lab. By placing 2 streamers on a model plane, Randy hopes to show that the airflow is strongest at the wingtips.
And to do that, we're going to tilt the front part of the plane up. Amy, if you can turn on our tunnel for us. And as we increase the winds, you can easily see that this wingtip is fluttering a lot more than the strip that we have in the center, because the high pressure air that is leaking around the edge of the wing is causing this oscillation.
This movement of air around the wing edges creates the wingtip vortex. In specific conditions, the weather and the atmosphere can have an even more dramatic effect. They allow the plane's wings to actually create their own clouds. A narrow, winding corkscrew of cloud lasting for hundreds, even thousands of feet. Low pressure in the center of the vortex is the cause.
If the air is moist enough, the low pressure actually causes the air to slightly cool, and we're going to get a little bit of condensation. We will actually see that. So we're going to oftentimes see this where you have areas of large humidity, coastal airports, for example, or where it's just rain.
It's a rare sight, rarer still if caught at sunset.
At dusk, when the sun is going down and the rays are just hitting the cloud particles to present this orange hue. When a plane flies through that, the wingtip vortices begin to create this kind of orange swirl, if you will, to create a picture that one will never forget.
So whether it's the radiance of the evening sun, the high humidity of a coastal airport, or just a wisp of cloud, wingtip vortices are brought to life for us all to enjoy. Still to come, an incredible snowstorm like no other.
The snowdrift on top of my van is over the roof. It's craziness.
Before you put any engine to bed this winter, don't drain the fuel tank. Top it off with Stayville storage. It keeps fuel fresh.